Hello and welcome to this video where we'll go into hands-on logistic regression with scikit-learn in Python. Here we will do classification, and before you have learned the theory and intuition about logistic regression, and now we'll go into the code. We'll also do some exploratory data analysis on the data, and then we'll do prediction with logistic regression, and finally doing some evaluation that you can see how evaluating classification works, so that you can see the different metrics being used in practice. Before going into the code, we'll find the dataset first. I'm into this webpage, statlearning.com, in Introduction to Statistical Learning, and we'll go into resources section here. In the resources, we have here for ISLR 2nd edition, we'll find datasets. We'll pick the default. The default.csv is found inside here. You need to download this all CSV files as zip, and inside there you'll see a default.csv. Pick that one. So here I am in Visual Studio Code, and you can see my default.csv. We can look at that, and we can open it in preview, that you can see it more like a spreadsheet. Here you have default, no, you have student, no, you have balance, and you have income. Okay, the thing is we want to choose what we want to predict, and we want to choose default. It could be no or yes. Before doing that, we'll set some things up. We'll start the UV-VNV to create a virtual environment, and the source.then activate it. And in Windows, it's scripts instead of bin. Okay, and now UV pip install. We will need IPyKernel to work with Jupyter Notebook. We'll need scikit-learn, and we will need pandas. What else do we need? Yeah, pandas. That should be fine, I think. If we need more, we'll install it on the way. Okay, close this down, and I will open a new file, and I will call this logistic regression ipnb. This is a Jupyter notebook, and now we will have a logistic regression like this. Change this to Python environment, logistic regression. Okay, import pandas as PD, import numpy as NP. Then we'll do exploratory data analysis. We will start with, here I will have, let's see, EDA, exploratory data analysis. And then we'll do df equals pd.read, not read clipboard, read the CSV, and we want to have default.csv and then df.head. This is the dataset, and we'll do df.info to check the dataset. You see the 10,000 non-null, and it's an object here for default and students, yes or no, while the other ones are float. Here you can see in describe that we have summary statistics. We have balance here. You have 10,000 in count. Yeah, what is the mean and income and standard deviation, mean, etc. Blah, blah, blah. You can read this to study the data. And we'll continue looking into what we have. df default and df default. Is this one is yes or no. Then we do value counts here, and what you can see is that it's mostly no. This means that this dataset is very unbalanced. Mostly it's no, very few yes, very few percentage is yes. Also, let's take a look into df student dot value count. You can see here is no and yes, but mostly no. However, this in default is mostly, it's unbalanced, okay? However, those that are default are important. We'll take a look into different metrics here, and you will see a large difference later on. Now we'll also need the Seaborn actually. Import Seaborn as SNS, but I don't have Seaborn. So let's fix that. Source.then bin activate. And then UV pip install Seaborn. Okay, done. Now I have Seaborn, and then I can do this sns.scatterplot data equals df, and we want to have x equals to balance. Check the y equals to income. Then I want to check like this. Seaborn is a quick way to plot the data in a quite neat way. Yeah, when I say quick, it takes some time to load it first time. Okay, now I've plotted it, and what you can see is that we have income and we have the balance. We want to see if they have defaulted. We can take a look into another dimension here. We can have hue is the color, and we choose the default here. What you can see is that mostly those with higher balance have a higher chance of default. As you've seen in this picture here. Okay, this graph can help for that. Let's make another graph here. Let's make fig, x equals plt. Oh, then I need to have a matplotlib as well. uv pip install matplotlib. It is installed, yes, because Seaborn is built upon it. plt.subplots 1. Let's see, 1, 2. Yeah, like this. Then 4x, let's see, we have to import it. Import matplotlib.pyplot as plt. 4x, call in zip x, we'll go into balance. We'll go into income. For that, then we'll look into the default. We'll look into the balance and income here. I'll show you what I mean here. sns.boxplot data equals df, x equals to default, and then y equals to call, x equals to x, and hue equals to default. What you can see here is that we have default as the x. Let me show you. Let me make this a little bit better. We can have fig size equals to 10,4, and we'll have dpi equals 200. Okay, good. Take a look into this. We have a box plot here for the default. Then we have y as the balance and y as the income. As you can see, there's default, no or yes. We want to see that here we have a higher balance, a higher chance of default, while the income, it doesn't seem to matter that much. That is what we saw with this box plot here. Now it's time for doing some encoding because we have categorical features. Note that in the theory, we saw that we should do either one-hot encoding or dummy encoding. Let's do dummy encoding. To do dummy encoding, we do df equals to pd.getDummies, and we have df here, and then columns equals to default, student, because these are the categorical features. In order to make it into one-hot encoding, we just do it like this. df.head, you will see how it looks like. Here you see default yes, student no, student yes, and it's true and false, and true and false becomes 1 and 0. And we can do drop first equals true, because the thing is, if it's default no, true, and default yes as false, then those are the same features. By doing drop first, we get dummy encoding, then it's not default yes. If default no is false, then it is default. What you do is like this, drop first equals true, and we'll get an error here. Okay, the error is due to, we have overwritten df. Just do run all here, and you'll see that it works. Okay, good. We have here, as you see, default yes as false and student yes as true. Then we wanted to change this true and false to 0 and 1. We'll get the df, and let's see, df default yes, comma, student yes equals to df default yes, comma, student yes, as type int, and we have df.head here, and you can see it's become 0 and 1. What we have done is that we just did as type int, they become 0 and 1. Okay, now it's time for logistic regression. What we have been waiting for, logistic regression. Let's see, change this to Python. Perfect. From scikit-learn.linear model, we're still in linear model, import logistic regression. We'll have from scikit-learn.model selection, import train test split, from scikit-learn.preprocessing, import standard scaler. Note that these are the different steps that we'll do in logistic regression and in general when we're dealing with supervised learning. But I will make most of the steps in same place that you will see xy equals df.drop. I won't go into the details of all the steps because I've done that in previous videos on linear regression. Default, yes. We'll drop that one. Axis equals 1. And then we'll have default, yes, here for the y. Then we'll do x train, x test, y train, y test, train test split, xy. We split it up with this train test split, and it needs to be in this order. And then we'll do scalar equals to standard scalar, and then we'll do scaled x train equals to scalar dot fit transform. Because it's x train, we can do fit transform. And then we'll do scaled x test equals to scalar dot transform of x test. Note that when we're doing standard scalar, we'll get the 0 mean and 1 standard deviation for the training dataset. But for the testing, since it's using the mu and sigma from scaled x from the x train, it won't be exactly 0 and 1 for x test, so for scaled x test. However, I won't show exactly the details. Model equals to logistic regression. Let's see, we will take a none in penalty that we don't use elastic net or L1 or L2 to take the most original model of logistic regression to just show that one. Model.fit, a scaled x train. We're training on the scaled x train and then y train as the label. We'll take a look into model.coefficient, model.intercept. These are the coefficients and this is the intercept. These are for the features, the parameters that we have trained up. Based on these ones, we will place it into, and in logistic regression, you have seen the equation for the logistic function. You have seen that there are W0, W1, W2, and these are the ones that are placed inside of this logistic function we put in these values to be able to predict on new samples. What we can take a look at, for example, we can take a test sample, pd.dataframe, take a look into balance. We'll just pick one balance, say 1500. I pick the values that are close to what we can see in the data. Income, we'll pick like 40k, for example. And then we'll have here student, yes. It's 1 and 0. 1 is student, 1 is not student. They have same balance and they have same income. Let's take a look into our test sample. This looks like this. We have balance, income, we have student, yes or 1 and 0. Based on this one, we'll try and take a look into scaled test sample because we need to scale it equals to scalar.transform. Our test sample, and then we'll do model.predict proba. This will give us the probability scaled test sample. Take a look into that one. These are the probabilities. What you can see here is that this is for, we have no, and then we have yes. Let's take a look into our ypred. ypred probability equals model.predict probab for scaled X test. Then we can take a look into ypred probability colon 5. You can see here mostly are no. Actually, all of them are no. Here is yes. We have a higher probability of no here. Finally, now it's time for us to do some evaluation. From scikit-learn.metrics, note that here, as before, this is 0.93, here's 0.99. I forgot to say that because here's 10 to the minus 1. It's the probability of its defaulting to no. No in default, that's the probability that it's trying to predict. While this one is for the yes. Probability for yes here is quite low. Okay, then we do from scikit-learn.metrics import confusion matrix, accuracy score, and we need classification report as well. These are different things that we're importing from scikit-learn.metrics. ypred equals to model. What we could do is that we could take the argmax here, or we could do model.predict directly. We can do scaled X test. Here you can see it's an array of 0, 0, 0, 0, 1. It's predicting on whether or not it's defaulting. 0 is not default and 1 is default. Then we can take a look into the accuracy. Is the accuracy score of y-test, ypred. Take a look into accuracy and you can see, wow, it's quite high accuracy. This is a super good model. Is it though? That is what I want to show you here, that when we do confusion matrix, CM equals confusion matrix, y-test, ypred, labels equals to model.classes, like this, and CM looks like this. We can do, let's see, we do display equals to confusion matrix display of CM, and then display labels equals a model.classes. Then we do this dot plots. Let's see, 2 equals. Okay, so this is the confusion matrix. What you can see here is that most of them are true negative. And then we have predicted it as 1, but it was 0. We have some false positive. Here we have predicted it as 0 as negative, but it was a positive. We have missed a lot of positives. This is a false negative. This means that the accuracy score, it's not very good metric to use. As you have seen, we have missed many cases that were positive. Then how come we get high accuracy? Because accuracy was defined as true positive plus true negative, or here true negative plus true positive divided by total number. As you can see, the dataset is really unbalanced. That's why the accuracy score is not good enough. What we can do is that we will take a look into the other ones by we can do it manually here. I'll show you. Accuracy, just accuracy equals to, here we have 3177 plus 33 divided by total. Total is 3177 plus 33 plus 77 plus 13. This is the accuracy. And then we can calculate the other ones. Recall equals to 33. It's the recall is the true. Let me take a look into the definition. Recall is true positive divided by true positive plus false negative. We have divided by, here we have true positive 33 plus false negative is 77. We can take a look into the recall. You can see the recall is quite low, 0.3. This is one that you want to get higher. You want to have higher recall. Then we have precision equals to, it's true positive 33 divided by 33 plus 13 by the false positive. We can take a look into precision. The precision is a bit higher. But in this case, you want to get the recall to be higher. And also you have F1, which is a weighted average of both of them. It's 2 times the recall times precision divided by recall plus precision. The F1 score is this one, 0.42. It's harmonic mean of those two. But in order to do this quicker, now when you know how the underlying calculation works, just do classification report of y test, y, and we should get the same values. Here it's impossible to see because this is a string. We need to print it out to get it nicely formatted. As you can see here, you have precision for 0 and precision for 1. What we did was calculated for 1. If you look into this value here, the precision for 1, 0.72 is same here. This is just rounded. Here we have recall for 1 is 0.3. You see the recall here, 0.3. And F1 is 0.42, which we had here, 0.42. Here they also have support, like how many of the samples that support this. Then we have here accuracy score, 0.97 is the one that we calculated. In this video, we have gone through logistic regression, starting with this dataset default.csv, and we did some exploratory data analysis and then followed through the different scikit-learn steps as we have always done, and doing logistic regression, but also showing how to do dummy encoding. And finally, we did evaluation to show you and not be misled by the accuracy score, because a lot of people may just talk about how high accuracy do we have on this model, but that could be really misleading as this model was actually quite bad for this data set. We didn't solve it quite well using logistic regression. There's other ways to solve it better. However, this is the results that we got. We shouldn't lie about it. We should take a look into the other metrics. You get to learn more about the different metrics, how to compute them, and take a look into the confusion matrix, and finally the classification report and how to interpret this. Yes, I hope that you learned a lot in this video, and see you in the next one.